ఇప్పుడు మాట్లాడమని చెప్పండి.
Check 1 2 3. Hello. Hello.
వస్తుంది, ఆడియో వస్తుంది.
Check. Check. Hello. Hello. Check. Check. Hello. 1 check. 1 2 3 4.
ఓకే డన్ సార్. ఓకే డన్. దేని గురించి అండి?
Good morning, ladies and gentlemen. On behalf of the Indian Society of Genetics and Plant Breeding, Hyderabad chapter, I extend a warm welcome to you all this morning for the panel discussion on utilization of modern breeding tools, perspectives, and a way forward, and the annual general body meeting of the ISGPB Hyderabad chapter. A warm welcome to our Registrar Sir, Dr. Sudhir Kumar, Director of Research, Dr. Jagdishwar Sir, and Dean of Agriculture, Dr. Seema, and to all university officers, panelists from different institutes, and ICR staff, and ICRISAT scientists, and also all the genetics and plant breeding staff and personnel from private industries, and our own university faculty of GPBR department and staff. A warm welcome once again to you all. We begin the program now. To begin with, I invite the dignitaries of today's event onto the dais. I request Dr. S. Sudhir Kumar Sir, Registrar, PJTSAU, and President of the Indian Society of Genetics and Plant Breeding Hyderabad chapter, to kindly come over to the dais, sir. I request Bindu to felicitate, sir. I now invite our Director of Research of PJTSAU, Dr. R. Jagdishwar, to kindly come over to the dais. And I request Nilima to honor Dr. Jagdishwar. I now request Dr. Seema, our Dean of Agriculture, to kindly come over to the dais. Lakshmi Prasanna, kindly welcome, Madam. It is a mark of our undying tradition to invoke the Almighty at the beginning of any important event. So let us all now have the prayer song.
Gajavadana Beduge Gauritanana Gajavadana Beduge Gauritanana Gajavadana Beduge Gauritanana Vijagavati Sujanada Purevani Gajavadana Beduge Gauritanaya Trijagavanditani Purevani Gajavadana Beduge Pasamusadhara Pasamusadhara Mushikavagana Munijana Pina Pasamusadhara Padamapita Mushikavagana Jana Pina Mushikavagana Munijana Pina Mushikavagana Munijana Pina Gajavadana Beduge Gauritanaya Vijagavanditani Sujanada Purevani Gajavadana Beduge.
Thank you all. I now request all the dignitaries on the dais to kindly light the lamp and symbolically inaugurate the program of today. Thank you all. I now invite Dr. S. Sudhir Kumar, Registrar PJTSAU and President ISGPB Hyderabad chapter to deliver the welcome address.
Good morning, respected Dr. Jagdishwar, Director of Research, Dr. Seema Madam, Dean of Agriculture, members of Board of Management, Dr. Jagan Mohan, Dr. Sundaram, who has joined online, Director IIR, Dr. Arvind Kumar from ICRISAT, who has joined online, Dr. K.C. Bansal sir, who has joined online, as well as Dr. K. Narayanan. Namaste sir. Dr. Vijay Kumar sir, Dr. Janila from ICRISAT, Umakant from Indian Institute of Millet Research, faculty members from different ICR institutes, from ICRISAT, faculty of PJTSAU, and different faculty from private industries. A warm welcome to you all to the Indian Society of Genetics and Plant Breeding Hyderabad chapter. I welcome you all to the first annual general body meeting as well as the panel discussion on utilization of modern breeding tools, perspectives and way forward. It gives me immense pleasure to meet you all after 1 year of this inception of Indian Society of Genetics and Plant Breeding. We have started this chapter with the main objective of to disseminate and update scientific knowledge, to promote association between the faculty as well as students among ICR institutes, ICRISAT, private industry, and to have a right idea on recent technological advances in the field of genetics and plant breeding. In the past 1 year, this chapter is trying to connect among the members of the society, and it has been successfully completed 6 online lectures by inviting members or inviting eminent speakers like Dr. Rajiv Vashne, former research programmer, Dr. K.V. Prabhu, Chairman, PPVFRA, New Delhi, Dr. B.M. Prasanna, Director, Global Maize Program, Dr. N.K. Singh, National Professor, Duty Paul Chair, NIPB, New Delhi, and others. And in fact, I'm very much thankful to the Secretary, Dr. Balram, for his constant efforts, not only for organizing this talks. Sir, kindly mute your, So I'm very much thankful to the secretary, that is Mr. Balram, who has taken constant efforts for arranging different lectures as well as for taking this chapter forward. As we have not met physically for the last 1 year, the executive committee of the chapter decided to organize a panel discussion on utilization of modern breeding tools, perspectives, and the way forward on the occasion of completion of 1 year, and also to organize the annual general body meeting. The topic is very apt and very much suits the present time. On my personal behalf and on behalf of PJTSAU and on behalf of the Genetics and Plant chapter, I welcome the panelists, Dr. Kailash Bansal, who has joined online, Sian Mais, research programmer, accelerator crop improvement from ICRISAT, Dr. P. Anand Kumar, former director, ICAR, as well as Indian Institute of Rice Research, Dr. K. Narayanan, former director, Saktya Seeds, Bangalore, Dr. S.V. Sai Prasad, principal scientist, plant breeding, Indian Institute of Rice Research, Dr. K. Mangroti, senior scientist, biotechnology, Indian Institute of Rice Research, Hyderabad. We all are aware that how new breeding tools are trying to fix the gaps in conventional breeding program and address several problems. Especially marker-assisted selection has many fruitful products. To name a few, improved Samba Mashuri for bacterial leaf blight resistance, MAS 946-1, Sharada, a drought-tolerant aerobic rice, Vivek, QPM 9 maize, etc. The knowledge of genomics resulted in development of Pusa 10216, the first chickpea variety to have drought tolerance through molecular breeding. That too, it was developed in a span of just 4 years. Another chickpea variety, Anagiri 1, a Fusiorum wilt resistant variety, was also the result of genomic assistance breeding. Longer generation times and seasonal constraints also have been restricting factors for scientists to develop new varieties. Addressing these issues, speed breeding protocols have been standardized in wheat, barley, chickpea, and pea for up to 6 generations per year. In India also, speed breeding facility has been established in 2021 at IRI South Asia Regional Center Varanasi, as well as in ICRISAT, which is expected to serve in breeding varieties with speed of climatic change. Today's panel discussion is organized with the aim to bring experts' opinion on one stage and the group to clarify on the recent advancements in the field of crop improvement. This can ignite the group members to form right ideas and initiate their experiments with confidence. I hope this group would definitely tap the benefit of attending this panel discussion and take active part in doubts cleared. With these few words, I also expect that there will be proper response from the different plant breeders from PJTSAU, because whenever we are arranging these online lectures, the attendance is very poor. I hope that from now onwards it will be increasing. So at least if we hear that, then we'll be having some doubts. We can get those doubts clarified, because you are the future generation. So you are going to guide the students. So your thoughts should be clear. Your idea should be clear. So with this, my best wishes to all the panelists and members of the chapter for fruitful session. Thank you one and all.
Thank you very much, sir, for your valuable words. I now request our Director of Research, Dr. R. Jagdishwar, to kindly address the gathering.
Very good morning to one and all. Honorable Registrar and President of the Indian Society of Genetics and Plant Breeding, Hyderabad chapter, and all the executive committee members. And particularly, I want to congratulate Dr. Balram for the good initiative that has been taken, and all the executive committee members and all the plant breeders. And also my colleague, Dr. Seema, Dean of Agriculture, Dr. Anita, Dean of PG Studies, and members of the Board of Management, and the panel members from diverse fields, MBPGR, ICRSAT, ICR institutes, and seed industry, and the most vibrant and dynamic plant breeders of very important group. And these are the main pillars for this university, and not only this university, for any institute. And also my dear students and members from print and electronic media. Once again, welcome to this very important and apt topic that has been selected by this group. Utilization of modern breeding tools, perspectives and way forward. So this is in this month we have organized 2 programs. On 6th to 8th we have organized a program on moderation of breeding in collaboration with the CJR and also IRRI team led by Sanjay Katyar and his team. So really again within the almost within 15 days we have organized another. This is an important program. So as rightly pointed out by our registrar, the main aim of this chapter or particularly to disseminate whatever the knowledge that is available or sharing of the information is the most important. And with this we can get a lot of collaboration and also the people connecting across the globe, that is the most important. So in this connection, we must appreciate, particularly I am saying after Corona, now this group, particularly the plant breeding group, has organized a good number of programs, both in online and also offline. So on this occasion, I request or give a big round of applause to the Balram and his team for making very number of programs. And with regard to today's topic, it is very important. As we are seeing now, India is facing a lot of, though the production and productivity has been tremendously increasing, but we are also facing some of the important challenges. The first and most important is the climate threat to the production. That is one of the most, and we are witnessing. Now we are seeing the changes in the climate, particularly the heat waves, the excessive rainfall, or sometimes drought in some places. Though the rainfall and the intensity has been increased, but it is not uniform. That is one of the most important aspects. And accordingly, we have to reorient our programs to suit these changes that are going to affecting the farming community. The second one is, the most important is the over exploitation or the misuse or the whatever you call, we are using the resources in a very indifferent way. What we require, but we are not doing that, and we are over exploiting particularly the natural resources, whether it may be soil or the water or the inputs. So with this, we are getting a lot of, particularly the deterioration of the soil is one of the most important aspects. We need to think of. Why I am telling this? Now, if you see the fertilizer consumption pattern, particularly among all the states, now Telangana is the highest consumption of the fertilizer. If you see, it is about 281 kgs per hectare. This is a very alarming situation as compared to India, that is about 131 kgs per hectare. So even both the Telugu states, they are competing. Now there is a need to think it in this direction. So whatever the varieties that are being developed should have low input use. That is one of the most important aspects we should keep in mind. And third one is, so how best we can optimize the resources, how best we can conserve the resources. So that is also an important, and also how best that are eco-friendly. So this is because now we are seeing the continuous or monocropping of the rice. Now we are facing a lot of issues. So one side, now the water is available. Now most of the majority of the farmers, they are going for rice crop. But continuous cultivation of the rice crop season by season, then we know what are the impacts. So already we are facing a lot of issues with that. So the government is pushing towards crop diversification. So likewise, there are a good number of issues and challenges are there in front of us. So at this juncture, and it is my customary, and also because this is one of the most important and dynamic group, particularly the land building and crop improvement. And here these topics, a good number of panelists are there. Now we are going to discuss and diverse people. There, right from now we are having Bansal sir and also Arvind sir and Anand Kumar and other distinguished colleagues from the private industry. So this is generally most important and also very useful topic, particularly for the youngsters. So we have developed good number of varieties for different ecologies, different agro ecosystems. But we must ensure, so what is its coverage? And there is a lot of yield gaps. So even if you take Telangana or even if you take any state, so there is a lot of variation from one district to another district. So though the varieties having very good potential when we are testing in our experimentals, but the same is not reflecting in the field when we are going to taking to the farmers. So that is the most important concern, and the government is also putting a lot of emphasis. And now, if you see, during our early 1950s, the food grain production was only 15 million tons. Now we have reached a stage of 318 million tons. So it is a very good quantum jump. That is a credit goes to particularly this group and also the other associated groups, NRM group, crop production, and other people, and more than that, the farmers. So it is the contribution given and also the varietal spectrum and also the technologies that has developed, and now we are reaching a stage of more than, now the target is more than 320 million tons. That is the target now the government has fixed. So in order to achieve and to feed this much, and at the same time by 2050, now we are reaching the population of more than 10 billions. So that is the challenge. So keeping in view, now already the breeders have developed a good number of varieties, but only thing now the concern is we must vigilant the changes that are being taken in and around. That is one of the most important that need to be kept in mind while planning our programs. Second one is we are having good technology, particularly we are very much pre-breeding or conventional methods. But how best we can integrate with the modern tools, that is the need of the hour. So all the breeders, the breeders equation. So it rely on 4 important components. The first one is the genetic diversity. How best we can create the diversity among the population. That is one of the most, if you create the most diversity, then you will get a good product. That is the most important. Second one is the selection intensity. So what is the intensity? What should be the criteria to go for a selection intensity? And similarly, third one is the accuracy. So what should be the selection accuracy should be there. And the most important is the reducing of the breeding cycle. So that is the need of the hour. So most of the times now the government and other people and even the farmers, they are asking a variety or the hybrid that is suitable or to different ecological systems and also amenable for different operations. So that is an important. So how best we can reduce the breeding cycle. So my only request is still we are following a lot of old methods. So there is during our recent 3 days workshop, we have realized many of the people you might have realized the innovations that have been evolved across the globe. So all these need to be incorporated into our conventional methods so that we can able to deliver the goods or the products within a short time. So that is so now it is taking almost 8 to 12 years. So now with the available tools and modern tools, now we can reduce the breeding cycle, and also we can also evaluate it within a short time, and so that we can deliver the products to the needy people. So another important aspect I would look, because a good number of people are here and good number of panelists are there and young breeders are here. So on this occasion, my humble request on behalf of the universities, so there is a good number of projects and a good number of funding sources are available. We are unable to utilize. So that is my request is kindly this platform, and Balram has created a platform and he has connected to many of the our people. So we must utilize this opportunity and develop the connect to the many of the international scientists and also at the national level. So this is the most important aspect, and we have to develop the rapport so that we can able to jointly propose the projects and other things, duly addressing the requirements for the state as well as also since we are working for the ECRIP also. So a good number of materials and also is available, and we can exchange easily and we can reorient the programs. That is my request. Similarly, the students also must rope all the PG and PhD students must be roped and they should be taken with us so that we can address the problems which are facing by the farming community. That is the need of the hour. So in routine way, we should not select the problems so that there is a need of the hour is the location specific problems must be need to be addressed. So we are having good connects, and the university also now inviting even the private industry also for addressing the challenges and also problems. So here Vijay Kumar sir and other people also here. So kindly utilize this platform. And finally, on this occasion, it is my privilege and also announce. And recently, the university and developed about 15 varieties. So on this occasion, I compliments and also my appreciation for all the breeders who have helped in developing the 15 varieties. Out of this, 8 are from through varietal identification and through the CVRC, and 7 from the State Agriculture University. So altogether, this university after formation now we have developed 61 varieties. So all that credit goes to the breeders. So and also I convey my thanks to the university administration for providing this opportunity. So and university is always looking to take or whatever the support that is required in terms of the financial or in terms of the human resource. So all that is now the university is helping a lot, and it is our responsibility to take it to the forward and also own it so that we can definitely achieve the target that have been fixed by the government, and also it must be in compliance with the SDG goals that is being given by the government. So with these few words, I wish that this panel discussion and today's deliberation definitely lead a lot of issues and also the new programs for the benefit of the farmers and also for the innovative technologies in the next future. Thank you, one and all.
Thank you very much, sir. I now request our Dean of Agriculture, Dr. Seema, to kindly address the group.
A very good morning to one and all. Respected Registrar Dr. S. Sudhir Kumar Garu, the President of the Society, Dr. Jagdishwar Garu, the Director of Research, the expert panelists from various institutions, the Secretary of the Society, Dr. Balram, the Dean of PG Studies, the Member Board of Management, Jagan Mohan Rao Garu, all the faculty members of PJTSAU, and also the scientists from various institutions, as well as the private companies, and also dear students. Congratulations to you all, because this is your second meeting, and the two which is being conducted in a physical mode as well as in a hybrid mode. We have several people who have joined us online as well across the country. So in fact, I think everybody would agree that research collaborations, or you can say partnerships, or participations in such type of a conferences or in any sort of a discussions are very deep, very powerful research traditions. So when you all assemble on a common platform, there is always a scope to understand or share information about what each one of you are doing in your domain. So this, how it benefits, how it is a synergy, is that once you share the information, it is not only going to enlighten the other person, but also gives him a scope how to take off further, or how he should not repeat the same work. Because you all must be agreeing that all our resources, whether it is a research funding or the natural resources, they are always scarce. And you have to put them to judicious use. So the judicious use comes when each one of you are going to pick a small domain of your work and then work together, so that the outcome would be much more viable. The spending would be much more, very smartly you can do the spending as well. So in this whole process, one important thing which any breeder should not forget is they have to start their research with the need identification. Unless and until you know the need, then whole of your research would go waste. So once you know the need, you take up your activity in that direction, then you should also focus on how this, your research outcome will translate into policy. So unless and until this research, whatever hard work you have put in, whatever amount it has gone into the whole process, the time which has gone into the whole research, it should not go waste. So it has to translate into action. The action can come only when it is implementable. So implementable technologies, definitely it should find a place in the policy. So that is how the research should take place. The second most important thing which I would like to mention here is we should also focus on interdisciplinary societies, because we can work in isolation to a certain extent, but at some point or the other, collaborations are very essential. Your familiarity with other disciplines are also very important. The acquaintance with the other scientists is also equally important. So unless and until you have the multidisciplinary societies, you cannot have a holistic development. The breeders have always been in the limelight, always been a pride for any of the agriculture development process. I hope that this type of a panel discussions and this type of a platforms will further encourage and motivate you to continue to remain the pride of the agriculture development process. So this panel discussion, I hope, will throw the light on several aspects, especially when you are all doing research in certain areas. You may be coming across several problems, several constraints, several challenges. So when you share those things, the experts as well as your colleagues may have some solutions. So these solutions which you might have not thought of or which comes through the discussions can be a ready answer for your constraint. So with these few words, I hope this panel discussion of today would definitely bring in a overall perspective on the new breeding techniques, what has to be adopted, what is the need of the hour, will thoroughly enlighten you. And then I congratulate Dr. Balram for organizing so many lectures from experts all through the year. And I hope he continues to do the good work, because though he is an administrator like associate dean, but still the passion towards genetics and plant breeding, he saw that it remains intact. So I wish you all the best, and I don't want to barge into the timings of the panel experts. Thank you very much. Thanks a lot.
Thank you very much, madam. With this, we now end this inaugural session. I thank our registrar, Director of Research, and Dean of Agriculture to have joined us here. And now we will begin the panel discussion on utilization of modern breeding tools, perspectives, and a way forward. We have 6 panelists and a moderator today.
Can't hear anything. This is Narayan here. I'm unable to hear anything. Hello. Hello, this is Narayan here. I'm unable to hear anything.
సార్ ఆడిటోరియం నుంచి
We now begin the panel discussion. It's my privilege to invite our distinguished panelists. We first have an online panelist. I warmly welcome Dr. Kailash Bansal, former director, ICR NBPGR, and Secretary, National Academy of Agricultural Science, New Delhi. We are very happy to have you here, sir. Sir would be joining. Sir is with us online. Welcome,
Thank
sir.
you. Thank you.
I now invite onto the dais Dr. Sean Mays, Research Program Director, Accelerated Crop Improvement, ICRISAT Patancheru. Thank you very much for joining us today, sir. I request Bindu to kindly welcome Dr. Sean. It's my privilege to invite Dr. P. Anand Kumar, former director, ICR NIPB. Sir will be joining us very soon. He is former director, ICR NIPB and ICR IRR. We will welcome sir as soon as he joins us. And we now have an online panelist. I welcome.
Thank you. Can you hear me?
Yeah, yes. Thank you very much, sir.
Thank you.
I now invite Dr. S.V. Sai Prasad, Principal Scientist, Plant Breeding, ICR IRR, Rajendra Nagar, to kindly come over to the dais. Thank you very much, sir. I request Nilima to welcome Dr. Sai Prasad. I now invite our next panelist, Dr. S.K. Mangrutia, Senior Scientist Biotechnology, ICR IRR, to kindly join us on the dais. I request Lakshmi Prasanna to welcome Dr. Mangrutia. I now invite on to the dais the moderator of today's panel discussion, Dr. Janila Pasupuleti, Cluster Leader, Crop Breeding and Principal Scientist, Groundnut Breeding, ICRISAT Patancheru. She has 21 years of work experience as a crop breeder and a geneticist in international and national institutes. She has led a 9-year multi-institutional research resulting in commercialization of the first high olive groundnut varieties, Gidnar 4 and Gidnar 5, in India that were dedicated to the nation by the Prime Minister of India. She has shared more than 100 high olive lines with partners in 10 countries. She manages 15 crop breeding programs in Asia and Africa on millets and 3 in legumes. And she is engaging stakeholders from private and public sectors, actively building network and partnerships in many countries, more than 12, 13 countries. And she has mentored 6 postdocs, 12 PhD scholars, 18 researchers from Africa and Asia. And she has to her credit 78 research and review papers and more than 30 conference papers, not to mention her membership in many of the academies and organizations. I now hand over to Dr. Janila. I hand over the podium to her to conduct the panel discussion. Welcome, ma'am.
Thank you, Yamini, for that kind introduction. And let me also, before I start, thank Dr. Balram. And then he's been, and what should I say, with this passion, he's been the backbone for this Indian chapter of Indian Society of Genetics and Plant Breeding, and then put together several lectures and this panel discussion. As this panel discussion is going to be a dialogue, I encourage the participants to think over, to have some questions to our esteemed panelists over here. Before we start, just wanted to set a stage with a few comments on what we are thinking about today. So the crop improvement, yes, I mean, we have heard from the inaugural session, is very important for the future food and nutrition security. And I want to draw your attention on two important things. One is the One Health concept, which brings together the plant, soil, and the human health in the perspective of the environmental sustainability. And the second thing, as Dr. Jagadishwar has mentioned about, think about the responsible use of resources and the climate change. So I think climate change, we are witnessing some of these changes, and I think we need to think about how we sustain the food and nutrition security, not only of the major staples, but also of the diverse crops, which are important for the consumption of the humans and the livestock. And I don't want to distinguish between the classical breeding and the modern breeding. I would say is plant breeding, and then the practitioners of the crop breeding would use the new tools as and when they come into the availability. It started with selection. We moved on to the cross hybridization and using different kinds of tools. We used mutagenesis, and then we are talking about transgenics and genome editing. And of course, in all these aspects, I think the genomic tools and understanding the genomic sequences has really helped us to move on, increasing the selection intensity and the way we do the plant breeding. And I also want to draw upon two important things to you all to think about. The one which was already mentioned in the morning inaugural session about the genetic gain. So we constantly, our pursuit in the crop breeding is to enhance the rate of genetic gain, number one. And number two is the operational efficiencies. We need to be both cost and operational efficient as we move towards using these new tools in our breeding programs as well. And another two important things Dr. Seema has mentioned this morning. Define your needs. That's what we are calling plant breeding, crop breeding by design. So we define a product profile and fully from what nutritional traits it needs, what productive traits it needs, and what industrial traits it needs, and then we move ahead to develop such a product so that that would be the right fit for the market and also the production environment. The other thing we touched upon is the data-driven breeding decisions. I think with new tools available, particularly from the data science and also our understanding of the qualitative genetics, should help us in using this data-driven decisions in our breeding programs. And I'll just touch upon ask you to think upon the multidisciplinarity. As we are talking about using these new tools, I think the knowledge from different disciplines, it could be pathology, genomics, bioinformatics, data sciences, machine learning, think a wide array, even from mechanization, the way we do the operations and all these things need to be coming. So I think for the crop improvement, please also think about this, bringing in this multidisciplinary sciences, even the social sciences, when we think about designing the products, these all need to be common. So with this background, and then thinking about this crop breeding as a very dynamic and constantly changing, what we are doing in the 5 years back may not be the same what we are doing. We constantly bring in the innovation in the process of the way we breed the crops and also the way we test the crops, so that the right products are out, and then we'll have directors announcing that so many varieties are released by the institute so proudly. So with that background, while you're thinking about your own questions, let me first introduce our one of the panelists today, Professor K.C. Bansal. I think most of you in this group know, but then let me take this opportunity to introduce him. He has his PhD from Indian Agricultural Research Institute and then advanced research from Harvard University. And he has been the coordinator of national project on transgenics in crops and also the director of NBPGR New Delhi of ICAR. And he's the first Nordman Borlaug chair of crop improvement of ICAR. And he's also currently he's the secretary of the NAS and is an editorial board member of Plant Biotechnology Research. And he has several publications, and he has been instrumental in implementing International Treaty for Plant Genetic Resources of FAO, and he has been the vice chair also from Asia for that. He has several awards. Just I'll mention one of them. It's Rafi Ahmed Kidwai Award from ICAR for an individual contribution. And I would like to also mention that he's been elected fellow of two important science academies, that is National Academy of Agricultural Sciences and also the National Academy of Sciences of India. Thank you, sir, for being here today with us. And I'll start off with the first round of question to you, sir. So you have this vast experience, right, from the
But then can you hear me? So before I check up the mic, can you hear me well?
Yes, I can hear you well.
Okay, thank
Before
you.
we start, I will also say that we were delayed by almost 30 minutes in the inaugural session. So maybe if you can keep your responses limited to 3 minutes, that would be really appreciated. And given your vast experience in the public sector and your own engagement with the private sector, being at the helm of affairs at the ICAR, we want to understand which of these public and private institutes have harnessed these modern tools in their crop improvement programs. And if you can share some examples from crops and also from the trades. Over to you, sir, Professor Bansal.
Well, thank you very much. First of all, Madam Janila, for this kind words of introduction, and thanks to the organizers for giving me this opportunity. And I really appreciate the efforts of Dr. Balram and others of the Indian Society of Genetics and Plant Breeding, the Hyderabad chapter, including the key authorities and officials of the university, to develop such a panel discussion program, which is very helpful, I'm sure, for the young researchers and the students. And I'm very excited to be here present myself with my very great scientists and fellow panelists. And the questions you have raised without wasting further time. And first of all, in fact, I would like to also acknowledge the efforts of Government of India. And I must thank the key officials of Government of India to have agreed and officially cleared the pathway of use of the genome editing tools for crop improvement in India. I think it's a very big achievement, and we must acknowledge it on every platform. Not only, that they allowed cleared, record time, Government of India developed the guidelines, and soon after that, the standard operating procedures have also been developed and notified, and which are very simple, and which is really one way that we should try to have such panel discussions more. And not only this, we should try to engage ourselves in developing the product, be it in public or private sector. And as you rightly mentioned, I think several institutions in the country currently are working, mostly, of course, public institutions, as you normally see, the research R&D is driven by, in India, by the public research institutions. And government has also its own priorities. And while some of them were listed by the key officials of the university during the inaugural session, as government always thinks about producing more, from less for more, of course, because population is always increasing until it stabilizes to a particular level, let's say to 1.7 billion, I'm talking of Indian population. But then when you talk of the institutions first, or maybe the crops, I would take up first. From the government's perspective, the crops, while we always need wheat and rice, which is mostly contributing to our, food grain production, kitty. But I think the important from the government's perspective is, can we produce more using such genome editing technologies? Because we have not been able to make much headway. While we have come a long way, no doubt about it. Particularly, I'm referring to here pulses and oil seeds. So therefore, the effort should be in using some of those genome editing technologies in pulses. Particularly, I'm talking about here like pigeon pea, chickpea, or soybean, or in oil seeds like mustard, groundnut, and there are others, which can be also utilized. But of course, wheat and rice certainly very, very important. Then we go down to fruits and vegetables again. Like, if we want to prioritize, I would say banana, papaya, even potato for that matter, for viral resistance diseases. And also, pomegranate is a very important crop from Indian point of view. And even, I think papaya, if I missed that. So these are some of the crops and where we need to focus, but I would say that we need to prioritize. And that's very important, one aspect. And second aspect is with regard to the traits. There are certain traits which are very important across the crops, which we may like to now incorporate using genome editing tools. And that I'm talking about here is, for example, as was also referred before, climate resilience is very important. We always talk of individual resistance tolerance to various stresses like drought, heat, salinity, or submergence tolerance for that matter. But I think with regard to climate resilience is important. If we can try to incorporate some of those multiple stress resistance traits would be important. Not only that is tolerance or resistance to only one particular abiotic stress, for example, even I would say, can we combine these multiple stress tolerance and resistance when you talk of both abiotic and biotic stress factors. So that will be very, very important. Climate resilience. And second is, can we have a shorter duration varieties of different crops? That's also one of the government, priorities, shorter duration crop varieties to save resources and time and can harness the value of that product which will be available, to the consumers. And again, it's very important today, like for example, classical plant breeding, we have been always talking about it right from the Green Revolution days to produce more quality, more quantity. And in the process, we have been always using more of irrigation water, more of fertilizers, more of agrochemicals. And of course, we've been using more of time also, I would say, and for that matter, even land. So can we try to now increase the use efficiency of some of those inputs? For example, land, water, as irrigation, or even fertilizers for that matter, or even agrochemicals. So that amounts to, making some of those crops which are highly efficient in not only taking up some of those nutrients and water, and can we try to even save land and time for producing more, from the same area, or can we even reduce the area while still increasing our total food grain production? So some of those traits are now rather more important than, I would say, even yield for that matter. I would not focus as much on yield. Of course, some of the crops breeders will always talk about it, but I think we must have kind of a paradigm shift or kind of a discussion and prioritization. I said mentioned before what we need now in India after hundreds years or more than 100 years of classical plant breeding. Unfortunately, we have some of those excellent tools now available, which can increase the accuracy, the efficiency, the pace, and also with lower resources and money. And of course, resistance to various diseases and high yield, I will always keep it. Coming quickly to, I will just take a minute more on the institutions. Mostly these are ICR institutions currently working on it. Rice, even I may start from the Indian Institute of Rice Research in Hyderabad. Congratulations to them. They have already developed the genome-edited Samba Masuri with about 30 to 35% increase in yield. But that's important. Again, in India, in New Delhi, IRI, Dr. Vishwanathan's group is working, on saving water. For example, can we save 30 to 35% even more? Water, so we can be, directly planting some of those rice at direct seeding, also, quite possible. So IRI, Indian Institute of Rice Research, also the National Rice Research Institute in Cuttack, with the crop perspective, Tamil Nadu Agriculture University, ISGPB, and Indian Institute of Pulses Research, and several others, including even SAUs like University of Agricultural Sciences, Bangalore, or PIU Ludhiana, and some of the international institutions like ICRISAT is doing wonderful work in the guidance of Dr. Arvind Kumar. I know it that they are making great focus on particularly oilseeds and even millets possibly, and also ICARDA. One of these are the institutions other than ICRISAT who have their presence in India, ICARDA, Indian Institute of, or International Rice Research Institute, or even CIMIT. And some of the other institutions like I know about, Birla Institute of Technology and Sciences in the Hyderabad campus, or the Tata or the Energy Resource Institute, and also Gujarat. There are several of them. But some of the major institutions, of course, come from, basically I said ICR institutions, and in private sector, the dominance is only currently by MICO. I'm sure the others are also. We have a very good, speaker and an excellent scientist, Dr. Narayanan. I'm sure he'll be able to probably throw more light. But I know mostly about MICO working on rice for increasing the yield, and of course, Agrova, Cortiva Agri-Science moved out of India, but nevertheless, they still. I'm just reminding you all targeting some of the crop for Indian agriculture as well. So this is in brief. At the moment, I will stop here, and if there are certain questions, I'll be able to answer those. Thank you, Dr. Janila, for the time.
Yeah, thank you, Professor Bansal. So you touched upon the proactive government of India's legislation to deregulate the genome-edited products, and also on minor crops like oilseeds and pulses, some of the key traits, particularly input use efficiency and climate resilience. Thank you for that. We'll come back to you. And now let me introduce our second panelist, Dr. Sean Mays. He's Research Program Director of Accelerated Crop Improvement Program at ICRISAT, and he's been with us for a couple of months now at ICRISAT, and before that he was with the Nottingham University, and he has obtained his degrees from University of Cambridge, and his research interests focus on genetic diversity and germplasm characterization in crops, marker-rested selection for genetic improvement. And he has worked on several crops like wheat, oil palm, rice, groundnut, bambara groundnut, winged bean, foxtail, and others. And he has helped to establish a crops diversification unit within the Developing Food Institute at University of Nottingham, UK, before joining ICRISAT. And he has several publications, 130 peer-reviewed papers, and he has co-edited the genetics and genomics of oil palm. And he has a vast experience in oil palm industry, particularly in using genomic selection for oil palm breeding. So from that experience, Sean, I would like to, this group wants to know what are the considerations breeding programs, institutes to take into account for making the decision to move and use genomic selection? Good.
Thank you very much, Dimma, and thank you to the organisers and also to the university and obviously all of the audience for coming to this discussion. My main interest in many ways is in diversification, so minor crops. But I've done a lot of work in oil palm, and I started my career in oil palm a long time ago. And more recently, I've worked with Sime Darby in Malaysia, particularly on their genome project and putting forward their genomic selection approach. And I think it's quite an interesting experience. And also, to a large extent, you come across lots of issues that you hadn't really thought about. So using that as an example, I think the first thing you have to decide is whether genomic selection is appropriate. So particularly when you're dealing with large or potentially long-lived species, then your breeding cycle is quite long. So in something like oil palm, it's about 12 years for the female side. So really the only progress, or one of the major progresses you can make is perhaps less in gain, but more in terms of gain per year. So if you can reduce the breeding cycle, obviously you're making quite good progress. And that's driven a lot of the thinking, really, certainly in oil palm, is how do you, to a conventional program which will produce hybrids, because you need a tenor of shell thickness, which is thin shell, and it gives you more yield than the thick shell dura. And that's a single Mendelian gene, and that really has driven most of the breeding side of things. How do you work with that system to actually increase your speed of production, as well as potentially improve the accuracy of selection? So really it was in 2013 that Genome was published by the Palm Oil Board of Malaysia. And from there, things have moved forward quite rapidly in many ways. Understanding the diversity of the material you're working with is important. So as an example, in theory, the female side of oil palm in Malaysia and Indonesia comes from 4 palms. Now, that seems very unlikely, and obviously when you start using molecular markers, it's quite clear it's not true. But the problem is, unless you know your material and you know the pedigree, there are lots of errors that get made because you assume things are right, which are not. I've worked with a wide range of breeding industry, and in practice, the logistics of a breeding industry and the numbers of plants you deal with mean that mistakes will get made. So really, the thing that I think I've learned over the last 25 years is you start by confirming what you're working with, particularly if you're taking data from that, trying to model with it. And certainly in oil palm, the material in Sime Darby, which actually comes from 3 different plantation programs, has a lot of errors. And it's true of almost every program I've looked at, there are errors in it. So if you start applying something like genomic selection on the basis of evidence that's coming through from phenotyping, there's a big danger that actually your accuracy will drop simply because the material or the phenotyping data doesn't genuinely relate to what you're looking at. For something like oil palm, you're dealing with an outcrossing species, and that's difficult. It does mean it's very difficult to be absolutely confident your cross is pure. And then if you apply selection, high-level selection to that, anything that isn't impure potentially may get preferentially selected. So again, a really good quality control is critical. Then it really comes down to the population structure and the genetics behind a lot of things. And really, with the old palm stuff in Sime Darby, the population we were looking at in terms of sending forward was really the hybrids, and we started with something like 7,000 genotyping hybrids with about 200K chip. And from that, it was possible to identify the breeding populations, but also where we were getting good quality material. And this phenotype data would be at least 10 years old. So the phenotype data is probably coming from before we understood what was possible. I think then it was really a case of looking at the most appropriate populations in terms of the breeding stuff. The genomic selection works well if you're working with effectively the material that underlies your breeding program. But if you have different origins, so if you have material coming potentially from different sources, that also has an effect. So your most accuracy occurs when you're working in the same breeding source and the same material. If you start applying the algorithms to different breeding programs, the accuracy will drop. It also, the other major thing is it also has there's a real effect in terms of where your phenotyping data is coming from. So in old palm, there tend to be inland and coastal plantations. In this case, the phenotyping data came from the coastal location, which very seldom has a problem with drought. And when we applied the same algorithms basically to the inland, we weren't getting as much accuracy. So you need to think about all of those things. And then the biggest problem, certainly something like old palm, is simply applying it. So most plantations will have 148 palms per hectare. Somewhere like Sime Darby has 500,000 hectares in Malaysia, and maybe 5% of that's replanted each year. Of seed production, but also the initial way this was done was really using an algorithm to screen individual seed. And it can be done, but obviously it's not the most effective place to be in terms of doing that. So the next stage was really going back and looking at the parents and identifying through modeling those crosses that would produce the best combinations and the highest number of combinations of those selected ones. So material was planted in 2016 in the field. It's now 7 years old, so it has 2 or 3 years of yield recording so far. And that worked quite well. And the main reason it worked quite well was because you have to be very careful about what trait you select for. So you can select for multiple traits. Ultimately, you have to ask the question, what actually is it that the plantation is trying to do? And in this case, it was decided that selection criteria would be all per palm, because density of palms can change from different locations and potentially different plantations. But what you want is as much oil as possible from a single palm. And that was what was applied. And at the moment, the modeling based upon the initial data suggests there's probably a 20% increase in yield. That will be used for another 2 generations. So the crosses for the next generation have been made, and they are being selected on the basis of the model from the generation before. So again, genomic selection allows you to turn it around as soon as it's fertile for a couple of generations. So in that case, it's about 3.5 years instead of a selection cycle, which is 10 years plus 2 for the making and growing. What you do then have to do is you have to look at redoing the whole process, because you're changing the allele frequencies quite strongly when you do high selection. So the model may not be as applicable after 2 generations. But realistically, I mean, if you can get through 3 generations in 10 years instead of 30 or 35 years, that's a very significant genetic gain, as long as your accuracy is there. The logistics are pretty horrible in terms of doing all the fingerprinting and dealing with the number of palms, but it can be done. So if it can be done in all palm, it really can be done in most things, to be honest. And I think I'll leave it there for that example.
Thank you, Sean. Yeah, I mean, I think it's nice way of putting it with an example, particularly looking at quality control, knowing the population structure, which should be relatedness to our breeding populations, and also the phenotyping, and the need to keep on calibrating and validating the model, because you have a model, but then because allele frequencies will change. So I hope, I think that's an experience from the work which he has done. Thank you, Sean. We'll come back to you, particularly on the question of speed breeding later again. And now, I feel privileged to introduce Dr. K.K. Narayanan. Can I request you to put on the video if you are okay with that, Dr. Narayanan, so that the audience can see you?
I can hear you, but I'm not able to put on the video. It says audio only mode.
Ah, is it? Sorry about it. Yeah, sorry about it. So, I would like to introduce Dr. Narayanan.
The video, I have to put it on.
I'm sorry, can you repeat?
Somebody may have to on the video mode for me to share. Otherwise, I'll be on audio.
It was actually open. All other online participants were put on their video. So
Yeah,
that's
but
unfortunate.
Why it says audio only mode?
Oh, okay.
It's okay. Go ahead, please. Yeah.
Okay. Thank you. So he has his PhD from Tamil Nadu Agriculture University, and then did his postdoctoral research at Stanford University. And he joined SPEC Science Foundation Chennai as the lead of crop transformation and functional genomics program at the Monsanto Research Center. And in 2002, he co-founded MetaHelix Life Sciences, a Bangalore-based AG biotech company. And then he later co-founded and chaired the board of Kotaram Agrofoods, a food technology enterprise. And they also have a brand name, Soulful, for traditional Indian grains, that is ragi. And Dr. Narayanan has been a member of several committees and advisory boards and task force and working groups of Department of Biotechnology. He's a member of the Vision Group of Biotechnology set up by State of Karnataka, and he's executive council member of the executive council of Association of Biotechnology-led Enterprises. And he's also involved in social and community development projects as well. And with this, with your vast research and entrepreneurial experience in the field of ag biotech, would you like to share with us the policy environment around the product development using transgenics and also genome editing? The morning Professor Bansal has mentioned about the deregulation of genome editing too. And do you see any challenges? Before that, can you also comment upon the private industry's use of the new breeding tools in their crop improvement programs? Over to you, Dr. Narayanan.
Sure. Thank you very much, Dr. Janila. Good morning to all of you. I must say that I am on my way to the airport, so if you are having consistent reception, I hope you are able to hear me.
Yes, very well.
Okay, good. So first on the private industry using some of the new tools, of course we heard this morning the welcome address, the registrar talking about some of the efforts of the public sector system and Dr. Bansal elaborating it further. I think one of the first products using markers was in rice placed by Bayer. They had one of the leading hybrid rice varieties at that time, 6444, and they incorporated the bacterial leaf blight resistance to it through markerized selections. They released it at 6444 gold. And so since then, I think many private institutions have incorporated several traits, including starting from bacterial leaf blight. Some of them have certain blast tolerant genes, and they are all commercially available. So today, I think can actually get a premium if you have some of these traits incorporated. Another very commonly and widely used trait which was introduced through marker-aided selection was the submergence tolerance in rice, the sub-1 locus. There is Jaya. Much of the work happened in the public system, but the private system has also now incorporated it. And many areas where there is excess rainfall and there is flooding, sub-1 has come in very handy. I can go on and on. Several of them are in the works, but several of them are in the field, commercially available. Coming to just a comment on the use of markers, of course, our public system as well as private system has done a lot of work on trying to translate marker-assisted selection technology. But I think that the output in terms of practical products is still not commensurate with kind of the efforts that go into it. At least 3 points need to be kept in mind, because particularly when you do academic research, to make it translatable, it's very important that number one, the likelihood of descent of the identified marker or the QTL marker has to be sufficiently high. It may not be so if you want to publish a paper, but if you want to really translate it into a product, I think if you will take a large score of anything below 4 or 5, it may not be really practically useful. The second point I would like to make in this context is the contribution of the marker or the QTL, whichever type of marker it is, to the phenotype. Variance of the phenotype should be at least 25 to 30%. It should be significant. Otherwise, 5 or 10%, if a commercial establishment will find it difficult to actually translate it or worthwhile to pursue it. And the third point I would like to make on this is, it is always better to test a marker, or especially QTLs, under different genetic backgrounds. We work in a certain specific cross combination where it was discovered, but I think the reliability and usability of these will be much higher if it works under diverse and wide backgrounds. Much about the marker work, and quickly going on to genome editing. There are many institutions, both in public and private sector, which are now building the platforms for genome editing. And the recent revelations, which Dr. Bansal alluded to, making the commercialization of SD1 and SD2 events less onerous and more practical. I think it will go a long way, the application of this technology. I think here again, I would like to say when things are introduced, it becomes fashionable for everybody to use it. But then much of that effort will fall by the wayside because that will end up in a wasted effort. I think 3 or 4 things to keep in mind. I think the genome information of the crop in which you're going to work has to be thoroughly worked out. And the genetics of the trait that you are interested in should be thoroughly worked out. The functional validation, the gene to phenotype functional validation has to be as thoroughly done as possible, because you're trying to edit or change some of the sequences in that region, and that should really result in the desired phenotype. And finally, I think in genome editing, there are several IP issues, particularly with respect to the nuclease that is being used, Cas9. CRISPR-Cas9 is the most facile and widely used system today available. And maybe as long as it's academic research, you're doing it for research sake, may not really try to make a commercial product out of it. And particularly when the world is one, you can breed in India for the world, or you can breed elsewhere for India. and such movements are going to be more frequent in future. You need to worry about the IP positions. In fact, I have a suggestion that given the number of institutes that's there and all, efforts should be mounted to actually identify Cas9 like alternative proteins, because the CRISPR system is so widespread among the microorganisms, and we should come up with similar nucleases which will have similar functions. So genome editing is going to play a major role along with many other techniques. But as one should realize that these are all tools, and the tools need to be used appropriately. You use a screwdriver for a certain purpose, you use a spanner for a different purpose, and that choice has to be intelligently made by the breeder or people involved. And I agree with one of the earlier speakers at the inaugural session, that crop improvement research is not just about genetic enhancement. That's a major component. You create the potential, but for realization of the potential, you need all the other disciplines. It could be agronomy. So crop improvement in a larger sense, a wider sense, includes all the other cognate disciplines as well. And today research is data driven, and data science, artificial intelligence, and they all have a role to play, like the moderator initial remarks commented. I think I will stop here. Thank you.
Thank you so much, Dr. Narayanan, for touching upon the translational research, the IP issues, and more importantly, the multidisciplinarity of crop improvement. Recently, ICRISAT has conducted a 21-day training program on new crop breeding technologies for young and mid-career professionals from ICR, SAUs, private, and also Department of Biotechnology. There, we had a conversation when one of the participants said, breeder is the leader. And from there, towards the end, I think he was almost kind of convinced that crop breeder is also one important part of the big jigsaw puzzle, wherein different complementary discipline teams are added as different pieces of that puzzle. Thank you for bringing up that point again. So let me move on to the next panelist, Dr. S.V. Sai Prasad. He is Principal Scientist from Indian Council of Agricultural Research, Indian Institute of Rice Research, and he has his PhD from Indian Agricultural Research Institute, my senior at the Division of Genetics at IARI. And he has developed 27 improved varieties of different crops, wheat, oats, field pea, and lentils. And he has also developed among the wheats 6 biofortified wheat varieties. And he has been a recipient of several awards. Let me mention one, BGRI Gene Stewardship Award, and from the and ICR Team Award from NAS and other awards. So he has a long experience in developing as a plant breeder and developing varieties and rolling out with them. So with this background, I would like to ask you, do you see the knowledge and infrastructure gaps in the public sector institutes to use the new crop breeding tools? And do you think the partnership between the institutes can bridge this gap? Over to you, Dr. Cyprus.
No, Dr. Janila, before he comes, sorry to interrupt. I may have to drop off in about 10 minutes because I am reaching the airport.
Okay. Okay, Dr. Narayanan. So maybe I'll just come back after Dr. Sai Prasad for a quick clarifying question, and then you can drop off after that. Thank you.
Okay. Thanks.
Good morning, everybody. Myself, Sai Prasad from Indian Institute of Rice Research. The question asked by Janila related whether the knowledge infrastructure gaps in use of new crop breeding tools by public sector crop breeding programs. Mainly this, we are using these modern plant breeding tools on the basis of the classical plant breeding. Because the classical plant breeding is taking a lot of time, so how to reduce the time and improve the efficiency, these new crop breeding tools are came, but this involves all the expert teams, like different disciplines like genetics, statistics, agronomy, biochemistry, physiology, bioinformatics, molecular biology, and economics. All of them as a team, we can give the more efficient values. So these are the tools which help to accelerate the cultivar development and improve operational and cost effectiveness. So in terms of knowledge about these new crop breeding tools by public sector crop breeding, mainly this ICR and SAUs and different public sector crop breeding programs, the breeders and scientists are well equipped with knowledge and technologies applied because they have been trained by good institutions like IRA and other international institutions where the actual technologies have been imparted to that scientists. And also to available literature, and they are upskilled and interaction at various forums. But the gaps are there. We cannot say that we are perfect. Public sector institutions are perfect. We have the gaps in terms of infrastructure facilities because many of the universities and public sector institutions are not so much good in infrastructure facilities because a lot of funds are needed. Apply new breeding at individual and institution level due to the crunch of the funds availability. Even now ICR and other universities are funding like anything for these new crop breeding tools like genomics and genome editing and everything. But there are gaps. So we must think of collaborations either between at national level or at international level at CGR institutes because they are well equipped with the technologies. So by working closer, we can involve sharing the know-how and technologies and bring in new value-adding varieties to farmers. It will help in raising income so that the public sectors can reinvest in breeding, both at the national and international level. So we must have collaborations with public-private partnerships also because a lot of public organizations are now coming to closer and we must work to reduce the gap between the release of the varieties which are taking more time by using these new crop breeding tools like genome editing and other things which are our earlier speakers are very well versed in ICRISAT, and even our Mangaturiya is also now working on genome editing, and he has shown practically that by genome editing we can increase up to 35 to 40% yield in our institute IIRR. So we have the expertise, but presently at a global level or also at Indian level, we are lacking the private sector investment, public-private partnership. We are not having that much of good public-private. Some private partnerships are going on, and therefore I perceive a good partnership between the public and private partnerships are to be strengthened at national and international level by utilizing the new crop breeding tools in public sector crop breeding programs. This will help the partners to explore replicable and mutually remunerative approaches and sharing the value of new products or varieties through public and private organizations so that the farmers will be benefited by these partnerships and we can utilize the new plant breeding tools to improve the efficiency of our research and we can give the products at a lesser time to the farmers. This is my thank you very much.
Thank you, Dr. Sai Prasad. Dr. Narayanan, are you still online?
Yeah, I am still online, maybe
Okay.
for another 5 minutes or so.
Okay, thank you. So Dr. Sai Prasad has touched upon this need for public-private partnership and also the translational research that is required because the government has invested already so much in genomics and genome editing and all those areas. So I would like to know your comments. How you see from where you are to further this public-private partnership as we for the translational research. Over to you, Dr. Narayanan.
Yeah, absolutely. I think public-private partnership is the way to go. In fact, we should have a seamless relationship between the public and the private. In the area.
Dr. Narayanan, yeah. We lost you in between. Are you there?
Seamlessly transferred to the private system, the commercial. Can you hear me? Yeah, I'm there.
Yeah, in between we lost you, but now we can hear you again.
Okay, I was telling that the public-private partnership is crucial. It is improving. the trust deficit that used to be there is narrowing, and so you will have more and more of these relationships. I think what is key is to get involved, both the partners, public and the private partners, at the early stage, so that one can see through. One of the impediments, particularly, with some of these new tools, is when it is fashionable, the claims should be done in a circumspect manner, so that the credibility is maintained. It will be fantastic if there is a 35% yield increase through editing of 1 or 2 genes in Samba Masuri. But then I think this needs to be widely tested. If it is also prematurely. Hello, can you hear me?
Yes, please continue, Dr. Narayanan.
Yeah, so I think we should work with the private system also, and then wide testing to actually establish these traits. Otherwise, whatever little credibility gains that has been there in the recent past, that should not get eroded. And this works both ways, both in the public and the private system. Sometimes private system also makes claims which cannot be justified or which is too early to be claimed. I think that's one thing that we all need to keep in mind. We know that when you actually develop technologies, there will be glitches. And as you grow it and use them, there will be issues that need to be sorted out. So hand holding and working together and trying to solve problems is the way to go forward.
Thank you, Narayanan, for those comments. Right, engaging right from the design phase. I think that holds the key for success of probably the private-public partnerships. Thank you for that, and also restraining from the early claims will also help to build in the mutual trust as well. Thank you for those comments. Valuable. So you can, whenever you want to do it, you can leave now. Thank you so much. It's nice.
The departure gate, so I need to just.
Sure.
Thank you.
Thank you. Yeah, it was nice having you on this panel discussion, and then I'm sure that the entire group over here has benefited from your perspective of it. Now we will move on to our next panelist, Satyendra Kumar Mangrav. Yeah, sorry, and thank you for correcting me. So let me introduce him to you all. Already some introductions has been done to him in the way of his genome editing product of Samba Masuri, which is yielding 35% higher yield than the than its parent. So Satyendra Kumar is a senior scientist, plant biochemistry at Indian Institute of Rice Research of ICAR, and he has his PhD from Indian Agricultural Research Institute, New Delhi, and postdoc from Purdue University. And he was a visiting scientist at Heinrich University in Germany during 2019 and at Louisiana State University. So he's known for his research in the area of host pathogen interaction, pathogen genomics, epigenetics, and molecular mechanisms of environmental stresses. And he's leading a program at Indian Institute of Rice Research on deployment of genome editing to create improved alleles in popular elite and mega rice cultivars of rice. And he has published over research papers and has been recipient of several grants from DST, DBT, and others. And he is an editor of Frontiers in Plant Science and other journals like BMC Plant Biology. And he has several awards. One I would like to mention is the 2019 award, Borlaug International Agriculture Science and Technology Fellowship Award for him. So thank you, Satyendra Kumar, for being with us. And then we want to hear from you how these genome editing tools can be used both for product development and also probably for candidate gene discovery. And in the for use in the new crop improvement programs. And also, Dr. Narayanan has mentioned about it, the issues related to IP when we wanted to do the product commercialization, while we are okay with the academic research. So could you also touch upon it and how we can, in India, the public sector can harness this through the navigate through this IP regime? Over to you.
Thank you, Dr. Janila, and also Dr. Balram for roping me in this important discussion and wonderful gathering. I think the question, if I put it, I will put in two different parts. Like one is how genome editing can be used by public sectors, and that either to supplement with or complement with private sectors. I think part of my response has already been covered by Dr. Bansal, who is also my teacher, and also Dr. Narayanan. If I see point-wise, I put it like more precisely, public sector institutes, what we can do right now. We need to demonstrate to the government and also to the funding agencies about the potential of technology so that we can convince them and also get better funding and also a more lenient way to succeed in genome-edited crops. So in order to do that, we have already well-characterized genes, well-established pathways that we can tweak with. And there are crops which have been standardized in terms of the tissue culture or regeneration protocols. So what I think or how I perceive is the first go or the first line of product that should be coming from the public sector is to tweak with the well-known genes and pathways and bring the precise products in the crops where you have got very good protocols. The regeneration protocols or the tissue culture protocols. Thereby, you will be able to convince the government and also the funding agencies and demonstrate the potential of the technology. And in parallel, what we can do. Many a times, like we are focusing the genome editing as a product development tool, but it is a wonderful tool for functional genomics. And in the crops where we don't have much information on genes and their functions, and also in some crops like well-studied crops, for example, like if I say rice, we don't have the information on understanding the candidate genes for false smut or seed blight resistance. So there are some traits for which still we do not have the information. So we need to prioritize the crops and prioritize the traits for functional genomics, and that should be our parallel approach. There we need to wait for product development. That's number two thing. I think very aptly Dr. Narayanan told that India is very rich in microbial diversity, and I think public sector, since we are more into the discovery part, so India needs to invest more in identification of better Cas proteins or efficient Cas proteins, which would be like our native to, and because of the diversity that we have, I am confident that we can get a good candidates in terms of finding the Cas proteins. And the fourth most important point is developing efficient transformation and the regeneration protocol of crops. So this because the public sector can invest more in discovery part, or when we are standardizing such kind of protocols that can later be utilized by the private industries. Transformation and regeneration protocol, because if you see, still for many crops we do not have standardized or very I would say promising protocols for transformation and regeneration. And it is not only in the crops, even we need to make it cultivars specific. For example, from our experience, I can say when we started working probably in 2016, and we chose Sama Masuri, and those who have worked on Sama Masuri, they will understand it's a highly recalcitrant genotype, and it took nearly more than 3.5 years for us to to standardize its regeneration protocol. So it's a very, very tough genotype to work with. So it's not only crop, we need to make them, as I said, the cultivars specific. Fourth, that public sector can invest is to develop our own CRISPR-Cas vector systems, beside getting from outside, and that part I will touch when I am talking about the IP issues. And also rejuvenating our local cultivars. Genomating is a wonderful tool, like some of the special genotypes which are otherwise wiping out because of some issues, either they have lodging problem or they are low yielders. And since genomating is such a precise tool that it can enhance their yield, and more precisely it can improve those traits, we can retain the original quality of those genotypes. For example, Manipuri black rice, or we call Navara rices of Kerala. I am sure the situation would be same in other crops as well. So it can be used as a wonderful tool to restore those genotypes and bring back in our plates. So now coming back to the second part of my question is IP. It's a very complicated field, I will tell you. Though I am not expert of IP but how, because we are also on the same crossroads. Like we have developed a wonderful product showing very good phenotype. And there are nearly 6,000 patents already filed in the US Patent Office with respect to the CRISPR technology, either CRISPR-derived products or the CRISPR technology itself. And most of those patents have been from US and China. What we know that a lot of things are still unclear. But the positive sign is that they are licensing, the technology, at least for agriculture use, agriculture product development, and also, the commercialization. So this is one positive thing. Recently, even IRI has underwent tripartite agreement between Harvard and Broad Institute and also Corteva to commercialize the technology. So it's a kind of, I would say, what I feel, because as a researcher, what I can say that we need a specialized wing or, the cell that can continuously watch on the developments on patents and also the IPs of CRISPR, because it's a very, very complicated issue. For example, CRISPR-Cas9 is one thing, but then there are different versions of Cas proteins. Like we have been using Cas12a in our system, and the patent is with some other inventors. So it's a pretty complex situation, and we need some kind of cell that can guide the researchers and also get the, approvals, necessary approvals in order to facilitate that. So yeah, that's my response. Thank you.
Thank you so much, Satyendra. So particularly he touched upon the need of investment. He said that demonstration of technologies is very important for us as researchers from public sector, so that we can attract investment into those new breeding tools. Just continuing upon that IP, Professor Bansal, you are at the helm of affairs with both ICAR and also Department of Biotechnology. What are your perspectives? How you think, Satyendra is mentioning about having a dedicated cell that can facilitate the public sector institutes for licensing of the genome edited products. So how do you think the ICAR and the Department of Biotechnology can facilitate this? What are your perspectives?
Thank you, Janila. I think Satyendra has already cleared nicely so much on IPR, but still the problem, of course, is very important to be tackled, And but I'm happy to announce, or in fact inform the public that Government of India is quite concerned about it by itself, particularly for the public institutions. So creating a cell, across an institution or a number of institutions may not work out that way. Important is that we have to take this important issue immediately, with the Central Government of India. And I said before, Central Government of India is already, working on it, and there's a committee already formulated. by the Department of Biotechnology. That committee is looking into what are the various options, by which we can circumvent this problem of, IPR issues. And mostly, as I think Satyendra mentioned, broadly speaking, these, patenting issue is with two institutions, Broad Institute, in US, MIT, of course, and also the University of California. And Corteva, smartly enough, of course, it's their business. They have taken the patent for commercialization of agriculture research and the products. So I think we need to deal with these two institutions, directly, from the Government of India perspective. One, as an Indian entity, I would say. In fact, I will go beyond public institutions, including private sector as well, because India together must work out the strategy to deal with, because we have already, I mentioned, in the beginning, that we have certain large number of crops, 26 crops that India is working on currently, with so many of the public funded institutions and private sector, as Dr. Narayanan mentioned, also coming in a big way. So while I say it's a money game, it's not that we need to work out any logistics. If I can really have a license to work and have a freedom of operation, that's what we should all leave it to the government. We must try to request them time and again, even through the state governments, those state agriculture universities. And there's no point in individual institution, individual scientists, taking this agenda forward. It must only be through the Government of India. That's what my experience is. And fortunately, I mentioned before, there is a committee looking into various options about it. So only thing is we need to expedite the committee's role here, and how quickly can we, but in the meanwhile, I would suggest strongly that irrespective whether it's patent or not, important is, as Samba Masuri they have already done, IRI they have also done in rice, that we must continue working some of those technologies, which are very important for developing a product, first of all, and we must prioritize. And here also, as Satyendra mentioned, I would just like to clarify a few things. Government, you don't have to convince government anymore, with regard to the use of this technology in a particular crop for a particular trait. They're already convinced. I must tell you that. I was party to many of those, decisions. But point here is that which crop and which trait are you taking it for the direct benefit to Indian agriculture? Not that I demonstrate for a trait which is no important for me at all. No, I would not like to even fund that program. So there are already, if I may like to share with you a paper which we have written in Current Science a few months ago, immediately after this technology was allowed by Government of India, free from biosafety assessments, that I would request to, I would send you all and request Janila and other organizers maybe to share it with all. There we have identified priority crops and the traits. For example, in chickpea, if you talk of dry rot, I'm sure Janila will know better than me and all these traits, but there are no gene sequences or genic elements which are responsible for it known to us, so that you can go and, do SDN1 and SDN2. So these are important aspects, that which crop and priority areas you're going to develop a project, which I'm sure Government of India is waiting for it to fund. So this is what so far about this. And if there are questions, of course, I'll be happy to take up at any time.
Yeah, thank you, Professor Bansal. I'm sure we will share that paper with all. And thanks for also sharing the insights about this committee and others, and how this facilitation to the public and private sector together as an India entity is being taken up by the Government of India. So we'll switch gears from genome editing. So I would like to know from the audience here present in this room if you have some kind of an clarifying question, or because now the panelists. So you can think about it also. And also those online participants, if you can type on the chat box, right? So that's the mode of, if you have, or raise your hands and then come in as well. So while you do that, think about it and come in. So let me ask Sean. So what are those new breeding tools? Okay, when I'm saying breeding tools, probably I'm also thinking about how we select the parents for our crossing from that onwards. Would hold promise in the coming next decade, and also your comment on the repeatability of the multi-environment testing trials we routinely do. Over to you.
Thanks, Janila. I think it's always a little bit of a difficult thing to predict how technology will develop in a decade, because I think most of us didn't really see next generation sequencing until it almost arrived. I think in terms of what we need, I think we need other ways and faster ways to do phenotyping, because I think that now becomes one of the major blockages in terms of getting accurate phenotyping data and being able to understand how strong the environmental influence is. So, I mean, that feeds in a way into multi-locational trials. And I think that is starting to happen, high throughput phenotyping, using either quite complicated systems like Lemnotech, which works well for small plants, or individual things like using NIR for protein quality or protein content. These are things that have the potential to give us more accuracy without really large-scale chemistry that has been used before. And I think in terms of the genomics or genetics, sequencing will continue. It will continue to decrease in price. One of the most interesting areas is really sort of in the nanopore sequencing, where as the accuracy of that increases, you can actually tell not just bases, but whether there's methylation, potentially whether there's other modifications. And as we understand more about how important agricultural traits are controlled, and in many cases it may not be purely genetic, there may be methylation or other responses, then I think we'll start to understand why some of maybe the traits that we spend a lot of time looking for, we don't find or we don't understand properly in terms of their inheritance, is some of those may not be at sequence level. Individual sequencing in the field, I mean, I know now in Nottingham we had basically a briefcase with a nanopore kit which could be it was taken to Colombia to actually sample coffee plants. So the technology will continue to get smaller, to get easier, and to get easier to work with. That does give us the problem that we end up with a large amount of data that really now is also becoming a bit of a bottleneck in terms of the bioinformatics that go with it. But I think that will change. I think that the computing power is increasing. I think our ability to develop things is increasing quite rapidly. I think what we should be thinking about to some extent is partly coming back to the idea of the yield gap and how we do multi-locational trials, because multi-locational trials in many ways are trying to identify material that's stable. So it's stable across a number of environments for a particular trait, which is good if your cultivar is going to go across a lot of environments. But we may be missing a lot of genetic gain that can be obtained within specific environments. And I think one of the things that we can do, and we will do over the next 10 years, is really take the idea of modeling a lot further so that information from well-designed multi-locational traits can be interpolated to different areas, to different conditions. And we are also developing lots of sensors that can go in field to actually identify those conditions. So I think that will be one of the major things that goes forward. So again, it's big data, and it's very big data. But it also helps us understand the genetics compared to the environmental interaction, I think. I would certainly say that one of the key things I think we will have to do is diversify a lot more, not just in terms of crops, but in terms of the way that the crops are grown. So for some areas like the UK, I mean, the UK, we grow lots of wheat. It's high quality, it's bread making usually. It's up to sort of 13 tons a hectare. But there are a lot of other areas in the UK that don't. They can't achieve those yields. And what we should be maybe thinking about is how to use land more productively, or to use much lower input systems which are still productive. And I think there are a whole range of interesting traits. I mean, there's bacterial nitrification inhibitors, which are produced by some. There's a nice paper in I think NAS recently looking at wheat, and that turns off the bacteria that take the urea and turn it into nitrates, which then get leached. So I think there may be some really quite nice approaches in terms of developing much more efficient systems, not simply from a genetics, but also from the management side of things. So maximizing water resources, looking at a landscape level, and then using those water resources as best as possible by matching genotypes that have been bred to be as efficient for that situation. And I think all of that's feasible. I think all of that can be done through a mixture of modelling and validation, and I think it will happen. Although beyond that, I mean, there are potentially lots of things that we probably haven't predicted yet, which will make a big difference. Obviously, IT on mobile phones is a fantastic resource for farmers as well as for researchers. So I think I'll stop there.
Thank you, Sean. So while we all do the predictive breeding, want to predict the performance of the trait based on the genotype or the performance of the lines, I mean, we always do that. So Sean chose not to predict what new tools, but then he indicated what is needed for the future, and he touched upon the high throughput phenotyping, the new sequencing opportunities from nanopore technologies, and also upon the modeling, which can further enable us to do our MLTs, right, predictions, so that we breed and deliver the right variety for our target population of environments. So any questions from the audience? I would really like to hear at least two at this stage before I have questions for Dr. Sai Prasad and Dr. Satyendra on high throughput phenotyping and next generation sequencing. So this is a dialogue, and we expect to have questions from audience for sure. Please.
Or can I ask a question?
Yes, Professor Bansal, after the person who is raised his hand from the audience. Introduce. You can hear Professor Bansal?
Yes, I can hear. Hello, I'm here.
1 minute.
No, I can't hear what is coming up. I can't hear, sorry. I can't hear the question from the audience.
He's coming in. Shiva is coming in.
Okay, fine. Take it easy.
Demonstrate, so
Yes, now we can hear.
I'm from ICRISAT. So I have one question, especially for the Sai sir. So the yield is a complex right. It's governed by so many genes. So from how your genome editing pathways and trials for increasing the Samba Masuri 30% yield. Can you give some kind of insights?
Yeah, it's question to you, Satyendra.
Yeah, Satyendra.
So yield is a complex trait. How you could achieve 35% of increase by editing one genome? We will come back to you after Professor Bansal. You want to come here, Satyendra? If you don't mind, please. Yeah. It's okay.
Yeah, it's a very good question. I would say most of these quantitative characters are also regulated by some of the master players. And if you tweak with precisely, I would say, because instead of jumping simply on a gene will not work, just knowing that it is a master regulator, because master regulators are very tricky as well when you tweak with. And when we started working, we did really lot of modeling and permutation combination analysis before entering. And if I say a gene, like before we started, we thought we knew the gene, and also so it's a gene. Now I say gene is not just a gene, like it depends on what kind of gene can give you a number of alleles depending on what kind of mutations or what kind of changes you bring and what places. So and then you will get dramatically different kind of phenotypes just by making changes in a particular gene. So yeah, your question is relevant. How we got the 35% is because of its kind of regulator which influences a number of downstream genes, and thereby it governs the trait. Yeah.
Thank you, Satyen. And Professor Bansal, over to you.
No, Janila, I will go with the audience first. I will come at the end, please, if there's time.
Thank you, please. So we have two more. So yeah, you'll be the next. Over to you. Please introduce.
So I'm Damodar Raju from EJTSA, Principal Scientist, Rice Breeding. When we talk of improving of this Samba Mashuri by genome editing, so what I feel that 35% yield increase. Can we say at this stage, or is it premature to say? Because first, I think we didn't get any product out of genome editing with higher yields across the crops, what I feel, what I know. Another thing is, when we talk of improving of Samba Mashuri, should not lose its characters. It should be like Samba Mashuri, except for yield. So, as earlier scientists from IKSR said, yield is a complex character, it is not qualitative one. But I feel it may not be possible to get that much of yield increase just through genome editing. So I'm not questioning the technology, but I got a doubt about it. So another thing is, when we talking about yield, should be very careful, because we can talk about qualitative character, but yield in a particular known variety where people know about it. So I want some clarification on this particular point.
Thank you, Dr. Damodar Raju, for bringing that point. And then that's an important point. I think whenever we are talking about yield, we need to first talk about the environment with which we are talking about, right? A variety which is giving in an X yield in a Y environment will not give the same yield at another environment. Thank you for bringing that. I'm sure the Satyan's work from research is at an early stage. But then that definitely, if that's going to the product, maybe on station trials, Satyendra, thank you for that. But then when it goes to multi-location trials and all, I think it would be further validated. And then Professor Bansal want to have a comment on this. Over to you, Professor Bansal.
Thank you, Janila. No, it's a point made by, I think, Dr. Raju, if I heard correctly. While the technology he appreciates it, but I must tell him that there are several such examples of yield increase globally when you go around. And of course, they test to be tested across the environment. There's no doubt about it. So one should not doubt all this. This is my sort of message to him. And second, the whole technology allows you to keep Samba Masuri as only Samba Masuri. There's no change going to occur. Please remember this. Genome editing is very precise, very accurate. You are only mutating certain bases or deleting, a certain gene function. You're not doing anything else, just like we do in conventional plant breeding or in mutation breeding, or even for that matter on, through genetic engineering. You have got so many genes getting located at different positions on the genome. Here we're taking care of all. This is a beautiful technology now available. So one should not, scientifically speaking, have any doubt. This is my request to all the audience, really speaking, we must appreciate the technology, that it allows us to do only little changes very precisely. And it saves a lot of time. Just one selfing enough, will give you, kind of a foreign DNA free product, and it leaves the Samba Masuri as Samba Masuri, except, a little change in that native gene of Samba Masuri itself, which is otherwise not possible with any of the other existing technologies so far, other than genome editing. I can talk more, but I think I should stop here. Thank you.
Thank you, Professor Bansal, for that clarification. Next to you, Dr. Kuldeep, you have raised your hand, right? Yeah. Did you? Yeah. And then here, and then one more you have raised, somebody raised the hand.
So
please introduce yourself.
Yeah, it's me, Kuldeep from IKSR. So I just have a small doubt regarding, like, we are modernizing all technology and all those things. So what about the things? We have our breeding material at experimental station. Really, it's going to reflect on the farmer's field. Did we need to think about that also? Because that's what I experience when I have my trial. So Sean, can you please comment on this and all other panelists also? And another thing regarding, we are talking about genome editing and all those things. So in case of rice and wheat, we have reached to the plateau, and from our green revolution to the up to this stage, we are just able to increase the crop responsiveness. What about the other traits like its photosynthetic efficiency and all other things? Can genome editing will help us there somewhere? We can go for like something like C4 rice or something like that. So I would like to have Satyendra sir also comment on that.
Yeah. So first, can I hand over to Dr. Sean?
Thanks. Yeah. Yeah, I mean, the ultimate question is why do you get good results in your breeding trial and you don't get good results in farmers' fields? And that's, I mean, an example in oil palm would be they can now get 12 tons of oil per hectare. The average yield is about 3.5. And I think that's where one of the key questions comes in. It's this question of yield gap. And I think part of it, well, a large part of it is going to be environmental, but it's also going to be management. And that's one reason to think about working at a sort of landscape level. So you can actually manage your resources as best you can, particularly if water is the most limiting. Because otherwise you're going to be very dependent on the weather, and the weather's going to get more and more erratic, I think. Genetically, I mean, I think we don't really understand a whole range of things. I mean, one of the speakers mentioned about putting your, say, QTL into multiple backbones, and that's really quite critical because gene-gene interaction is something we haven't really considered in any great detail. So there are lots of factors there in the complex system. It's affected by the environment, something like yield. You can use yield components, you can use a breakdown of that to try and get close to something genetically more heritable. But ultimately, a large part of the work we need to do is understanding those fields and understanding what problems. And we can address some of that genetically, and the rest of it will have to be in terms of management. And I think, I mean, just a comment on genetic. I think it's excellent that the Indian government has allowed this. I think it's a fact.
Yeah.
But it's in the context of dimensional breeding. So it's bringing in new traits.
Yeah.
And the stability of those traits in terms of being expressed, to some extent, I don't think we know yet. We don't have any examples. But where it will really have an effect is if we think about novel domestication, either of new crops or improving domestication of existing crops, so that we can actually get a better result. And those are the sorts of genes where you do get really big changes in terms of even complex systems like yield.
Yeah, thank you, Dr. Sean Mais. Over to you, Dr. Sai Prasad.
We can't hear him.
Oh, you can hear, sir?
Yes.
Every time at the information that can use where I was been here for about 22 years in the always you feel that the experimental yields will be always higher than the farmer's field. But if you see in practical terms in indoor, one engineer here utilized our varieties of wheat, and he has harvested more than 9 tons. Where our experiment was 6.27, because these are proved by crop rating experiment paper, and he has got an award from President of India. And then many farmers, with good management, they are able to harvest more than this potential. So it is not like that every time we feel that our experimental yields are better than the rest. There is a gap, but we must awareness about the management crop so that the yields can be increased.
Yeah. Thank you, Dr. Sai Prasad. You want to comment, Satyendra, on the genome editing? Is it audible, Professor Bansal? When Satyendra is speaking?
No, it's not, please.
Now, sir?
Now it is okay. Yes, please.
Yeah, so I think Dr. Kuldeep, he asked the question, and the first part of the question was that we have already achieved plateau as far as yield is concerned in case of wheat and rice. So I think that part I beg to differ. If you see in case of rice, India's average productivity is still 2.5 to 3 ton per hectare. And if you compare with China, they have only 29 million hectare of area, and we have nearly 43 million hectare of area under rice, and we still produce a lesser amount than the China. So we have not reached plateau as far as yield is concerned in case of rice or wheat. So still there is a lot to be done in order to fill the gap. So we need to work on these traits. So these are important critical traits because we cannot afford to have 43 million hectare of area under rice in years to come. It will shrink, and it is so those challenges are there, and that is where we have not. So that is one thing. Second part is you said that can we use it for enhancing photosynthetic use efficiency or converting into C4. C4 I will not go into because it's a pretty complex thing, but yes, you can use it for enhancing photosynthetic use efficiency. There are genes, it's a tool, genome editing is a tool. You can tweak with any trait, either abiotic stress, biotic stress, plant architecture, photosynthesis. It is up to you, like what you are looking for.
Thank you, Satyendra. So now Yamini, and after Yamini you can go.
Can I? Okay, sorry.
No, mine was not a question. Actually, it's just a suggestion. I feel it's great that the amount of yield improvement, if you're able to achieve by tweaking one of few genes of through genome editing. So I feel it's very great. But I feel I have one suggestion is that Dr. Satyendra has worked with Samba Masuri. That's very good. But we should also look into most of the times when we as breeders, when we breed for resistance, especially for biotic and abiotic stresses, we achieve resistance to some extent, or even to the extent that sometimes we also see resistance across multiple locations and multiple years also. We do have lines in the acreage system when we see the data, or even our own MRST trials, we see lines which are having resistance to multiple traits and sometimes across locations, across years also. But I feel that even quickly we must, when we get a technology, we should be enthusiastic and try to support Dr. Mangrutia and translate that into those kind of lines which already have resistance, because always the resistance and yield is very important, I understand, but given the climatic changes that we are seeing, resistance is also one thing which we cannot keep as a secondary thing. So both have to go in hand, and we have to quickly all translate it. I think that's my view. It's just a suggestion.
No, thank you for that comment, Yamini. Stacking the traits, right? Different kinds of traits together.
Can I add here, Janila?
Yes, please, Professor Bansal.
Yeah, in fact, I will take a little bit part from the previous question as well as this particular comment, which is very nicely made, I believe, by Dr. Kavita. Here there was a question. Yes, I think Dr. Satyendra already taken up very well that photosynthesis can be certainly improved through genome editing per se. But when you talking of conversion specifically, asked about C3 to C4, I have a doubt. Even through, otherwise with all the efforts we have not succeeded in having kind of conversion of C3 to C4, and I don't think we should really put more energy into going for that. Important would be therefore, and also to answer the question combining yield and resistance together, would be that can we take directly the benefit of wild relatives, wild species in rice particularly, which is easier than even doing in other crops, because it's already been done, for example, in tomato using genome editing. Because there are certain rice varieties or species, rather I would say, which have got double the rate of photosynthesis. When you talk of micromoles of carbon dioxide fixed per unit time per meter square per meter square, it is much higher than what we have got in cultivated type of rice, or which is as good as in C4 rice. So I think there's a possibility using genome editing tools. Only thing is, because genome of course has already been worked out very well in case of rice, you have to identify those genes. You will convert now a wild rice into a cultivated cultivar of rice, and wild rice will retain all those advantages of resistance to various diseases, as was mentioned by Dr. Kabira, even to environmental stresses, for example. Only thing is, you have to change the architecture, you have to add few other traits which are related to the yield, and even including, I'm talking about the photosynthesis, which will be retained in that particular species. So there's a possibility, and that could be done in 2 to 4 or 5 years of time, as has already been claimed by some of the recent publications on rice and in other crops. So I think important is to exploit the genetic variation otherwise at the species level and through genome editing, which is possible in rice and many other crops. Thank you, Janila.
Thank you, Professor Bansal, for that clarification. Before we take that question, I will ask the MSc and the PhD research scholars in this group to think about a question and ask the panelists. This is one opportunity which you shouldn't miss. Over to you. Please introduce yourself. Yes.
Excuse me, Janila, can I take a 10 minutes break, please? If you don't mind, I'll come back.
Okay.
Thank you.
We may close by then, I think so, Professor Bansal. You can go ahead.
Good morning, everyone. I'm Dr. Srijan. I'm working as Assistant Professor in Plant Breeding at Agriculture College, Warangal. In continuation with Mr. Kuldeep's question, I want to add to it, and also I accept with the statements of Dr. Mangrutia, stating that yield plateaus have been achieved already. I want to contradict this actually. Yield plateaus are being told by us only. There is nothing like yield plateau. What I mean is we cannot say this is the yield plateau for that crop. So I want to state this. And further, we have keep on breaking the yield plateaus over the period of time. So this one also I want to put it on record. And later, I want to quote a small quote that there are 100 ways of solving a problem, and these kind of tools are coming every day, and these are really useful, and we should not question these tools. We need to learn and say that this is one way of solving a problem. We have to identify that. And further, I also want to quote that as Dr. Mangrutia's discovery that negative regulator was been mutated or edited in rice. I want to quote that photosynthesis, only 1% of the sunlight which is falling on the plant is being used for the photosynthesis, all the activities for grain development and all those things. So not like C3 and C4. So we can even create a more efficient system in the upcoming days with this kind of negative regulator mutation mechanisms. So I also want to put up. If we young faculty may be given some kind of intern kind of thing to work with stalwarts in new technologies for a short period of time, at least 2 to 3 months. To work along with the stalwarts in their labs to acquaint with the new technologies so that we also can become a part and parcel of this system. Thank you.
Thank you for those comments, wonderful comments. I think you're touching upon the inaugural session comments made, wherein this is a knowledge sharing platform and we're looking to build networks among us, right? The group at Hyderabad is fantastic. We have several ICR institutes, a university, and the private sector is very strong and vibrant in Hyderabad. And I think this is the right atmosphere to have those networks and partnerships. Yeah, thanks for those comments once again. So any questions from the audience? Yes, can you please send the mic over there? Who is having the mic? Akada. Oh, I'm sorry. Where is he?
Please come in. Let's extend 10 minutes and just close this.
Thanks. Yeah. Yes, please.
Good morning, everyone. I'm Kiranmai, a PhD research scholar from PJT SAU. So my question to the panelists is, So since we are young researchers and soon we are going to be in the scientific community and we want to be in the field of R&D. So my question is, what are the simple reading tools which are yet modern, which we can implement in our research program to begin our work with? What would be your suggestion? What are the simple yet modern reading tools which we should be using in our reading program as young researchers?
To which panelist? So I will first ask Sean Mays to comment on that.
I think the first question obviously in terms of what is your project and what area are you interested in. I think there are some generic things. So being able to program is critical now. I mean, it's very important in terms of data interpretation. I think a lot of these technologies are, I mean, as has been said, they're tools. And they're tools that are used to do certain things. And generally speaking, you want to be looking at the entire toolkit. So really, it depends on your question, but then you can pick appropriate tools as to what you actually need to achieve your objective. And I think the key thing is having a very clear idea of what it is you're trying to achieve, why it's useful, does it work economically if you do achieve it, so would farmers benefit from it? How would you scale it out as well? I think one of the big problems that has happened, particularly in academia over, not so much now, but certainly 10, 20 years ago, it's not wrong for academics to investigate fundamental questions. But it's very seldom asked of academics doing that, how does that apply? How do you use it? So we have a lot of academic information, but the translation of that into doing something with real impact takes an enormous amount of time and a lot of money, and quite often you can't get funding for it. So I think you need to think of these questions before you start doing things. How acceptable is what you're trying to do? And will it make a 5% difference to a farmer's income, or will it double it? So it has to be big enough to be worth expending the amount of time and energy in your life to do them, I would say.
Thank you, Sean, a lot. So you want to comment? Professor Bansal, you want to comment?
Yeah, sure. I'm back. Thank you. I agree with, in fact, Son's comments to the young researcher. He has made it very clearly. And what I will add here is that, you must try to, first of all, develop your own thinking, whether you like to develop a product using these technologies like genome editing in a particular crop. And of course, you will do all that homework and exercise that which crop and which trait you would be more interested in, where there's a requirement by the farmers, for having this benefit of yield advantage and profitability. And another thing could be that as a researcher, since you have a long time to go, and you may like to take up something basic aspects of it. Now, for example, if I may help you in identifying what are the lacunae. For example, if I want to use even genome editing in a particular crop or a particular trait, I have the technology available, but then I don't have the right candidate gene to be mutated or to be edited, or I don't have, kind of a genetic transformation protocol directly in a particular variety which I want to see, flourishing in the farmers' fields. So, I would suggest that either of these two are still bottlenecks in our country for some of the crops. For example, I mentioned in my, brief presentation before, like in chickpea, pigeon pea, there are certain issues. Even in mustard, for that matter, there are important issues to talk with functional genomics, identifying a particular genetic candidate or the genetics of a particular trait, so that you can then collaborate with these people who are otherwise developing a product. You can be a partner there. So I would suggest you should go into those kinds of things. And before that, also to be useful, if you can go for a particular kind of a training in one of the international labs within country. Of course, there are certain wonderful national labs, particularly on genome editing. I'm talking about it. Or go with your own objective in mind to an international lab where we can all help you. And then come back to India. Of course, that's what I would emphasize, to give a particular product to the farmers the way you feel like. So I think it's important question you asked, and capacity building and all will go simultaneously with it. So this is what I would suggest. Thank you, Janila.
Yeah, thank you, Professor Bansal. I think Satyendra also want to comment, but before that, I want to say, just summarize and say it differently. Let the technology does not determine what you want to do. Please define your need properly, and there are various technologies. You can again see, which one fits, and then that you can bring in. And of course, capacity building, as Professor Bansal has alluded, would be very important to use the technology as well. Over to you, Satyendra.
Yeah, I will just say in 2 lines. In fact, modern breeding tools get simple. All these new modern tools are simple. That is why they are being evolved. The basic purpose of evolving new breeding tools to make it more simpler and more precise. And as a youngsters, you should not be afraid of attempting new things, because I would rather say this is a time you can invest more on attempting new things. Even you fail, doesn't matter. But then this is a time like you can learn a lot. So go ahead with the new tools. They are don't be afraid with their names. Looks like very complicated jargons, but they are very, very simple once you start working.
Yeah, thank you, Satyendra. I think we have Professor Anand Kumar coming in, or he'll take some more time. No. Okay. So before that, Umakant, you wanted to have some comment, right? You were saying something. Okay. Oh, it all depends on the resources. Yes, I think Dr. Mays also touched upon it. So it's all depends on the resources. So we have a question from that side. Yeah. So,
hello everyone, I'm myself Tejasvi. I'm working as research fellow in ICRISAT. Coming to this application of gene editing technology, I have just started my research career, but from my fellow researchers and all, I just saw that after applying this gene editing thing in actually I'm working on groundnut. After applying it and getting plants like targeting particular gene and constructing targets and getting plants, after 2-3 years of getting generations also, like sorry, first generation itself, we got chimeras. They have a very severe issue with this chimeric plants. Like after successful application of the technology into crop and developing it, if we face this sort of problem, we can't go back to beginning and again start getting plants again. So how to deal with that sort of issues in our research? Okay. Yes.
So many questions on genome editing. So rather this session would have been given alone. So yeah, this is where like your planning matters. When you like Professor Bansal very importantly he told, and also he stressed that when you select a gene, you're planning 50% or I would say 80% of success. It relies on gene and which part of the gene you are going to edit. Either it's exon 1, exon 2, or exon 3. For example, there could be many exons. So, and then what kind of edits you want to create? You want to create SNPs, you want to create stop codon, or you want to change the frame shift. So, it's like it's a tool, and largely depends on how you plan before you enter into manipulating a gene. So you need to do a lot of background work, read a lot about the gene and try to see how it behaves, connect those missing links to the available literature, put them together and develop a kind of prediction model that if you will tweak here, how other switches will be turning on or turning off, and what could be the possible implications, and then you start working on it.
Thank you, Satyendra. So I think we have indications from Balram that we have to close this session now. So it's an interesting conversation that's happening. So let me thank all the panelists today, so providing their perspectives, and also the audience. Yeah, over to you, Yamini.
Thank you very much to all the panelists, and especially to Dr. Janila. Thank you very much, madam, for wonderfully taking us through the views of all the panelists on crucial and critical aspects of modernization of crop breeding and sharing your own insights also with us. So it was a very interesting session to listen. So now moving on to the next program, it's now time to felicitate our guests as a token of gratitude from the organizers. I now invite Dr. A.V. Umakant, Vice President, ISGPB Hyderabad Chapter and Principal Scientist, ICR Indian Institute of Millets Research, to kindly come over to the dais and felicitate Dr. Sean Mays, Research Program Director. Accelerator Crop Improvement, ICRISAT. Thank you very much, Dr. Sean. It was wonderful to have you here with us today and listen to your views. I now invite Dr. Jagan Mohan Rao, Director Seeds, Seed Research and Technology Center, PJTSAU, to kindly felicitate Dr. S.V. Sai Prasad, Principal Scientist, Plant Breeding, ICR Indian Institute of Rice Research, Hyderabad. Thank you very much, Dr. Sai Prasad, for joining us today and enlightening with your views. I now invite Dr. C.V. Samir Kumar, Professor and Head, Department of Genetics and Plant Breeding, College of Agriculture, Rajendra Nagar, PJTSAU, to felicitate Dr. S.K. Mangrotia, Senior Scientist, Biotechnology, Indian Institute of Rice Research. So he has been the man in the limelight today with questions from students with a lot of interest on genome editing. I now request Dr. Balram, General Secretary, ISGPB Chapter, Hyderabad Chapter, and Associate Dean, College of Agricultural, Warangal, PJTSAU, to felicitate Dr. Janila Pasupuleti, Cluster Leader, Crop Breeding, Principal Scientist, Groundnut Breeding, ICRISAT. Thank you very much, ma'am, for moderating the panel session. Once again, thanking all the panelists. I also thank our panelists who joined offline, Dr. K.C. Bansal and Dr. Narayanan. Thank you very much, both of you, for sparing your valuable times. Yeah, they will be receiving. Yeah, they will receive the mementos by post. Yes. It's now time to thank the organizers for the panel discussion. I now invite Dr. I now invite Dr. M.V. Nagesh Kumar, Principal Scientist, Maize, ARI, PJTSAU, to propose the vote of thanks for the panel discussion.
Good afternoon to all. It is my profound privilege to propose the vote of thanks on behalf of the Hyderabad chapter, Indian Society of Genetics and Plant Breeding, on the occasion of the panel discussion on utilization of modern plant breeding tools, perspectives and way forward. Firstly, our heartfelt thanks to Dr. Kailash Bansal, former Director ICR PGR and Secretary NAS, for his valuable and innovative remarks. About his valuable and significant regards regarding the significant role of government or public sector research towards the food and nutrition security in the country, as well as future use of genome editing tools in crops like in pulses and oilseeds, and for trade treatment, and as well as the efficient use of available inputs and resources, and integrating the classical breeding with modern tools. So thank you very much, Dr. Kailash Bansal sir, and we will send the honors to you by 1 or 2 days. Then I express my heartfelt gratitude to Dr. Sean Mays, Research Project Director, Accelerated Crop Improvement, ICRISAT, for sharing his experience in oil palm research. And Dr. Sean mentioned about the importance of genomic selection in reducing the breeding cycle, as well as enhancing the selection efficiency. And also he's emphasizing the importance of training and the handling of training and testing population during the genomic selection. So thank you, Dr. Sean, for your very important and valuable remarks to the audience. And also, now I extremely thankful to Dr. K.K. Narayanan, Founder Director, Staika Seeds, who joined online for the discussion, and also he guided the participants while using the latest tools. The breeder should have thorough awareness about the genome information, genetics about the traits, then functional validation of genes, and also the IP issues in the present scenario related to the genome editing. So thank you very much, Dr. K.K. Narayan, for your valuable and thought-provoking remarks for the panel discussion. Similarly, I express my sincere thanks to Dr. S.V. Sai Prasad, Principal Scientist, Plant Breeding, Institute of Rice Research, mentioning about the infrastructure facilities with regard to the use of modern breeding tools in the present scenario. And also he called upon the collaborations between SAUs, national institutes and international institutes, as well as multinational companies like Corteva and DuPont, etc. Thank you, sir, for your remarks. Then similarly, I thank Dr. Mangurutia, Senior Scientist Biotechnology at Indian Institute of Rice Research, who has been working in genomic selection over a period of time, and while comparing the public and private sector research, he has quoted that the use of new breeding tools, and also emphasized the importance of functional genomics in the crop improvement. So thank you, Dr. Mangurutia. And finally, we are extremely thankful to Dr. Janila, who acted as a moderator, as well as introducing the participants and panelists in the discussion, and also summarizing the discussion and making the discussion lively, as well as she also quoted some of the important decisions to be taken by the government with regard to strengthening the public sector research in the use of plant breeding, modern plant breeding tools. Thank you very much, madam. And our sincere thanks to the President, Hyderabad Chapter ISGPB, Dr. S. Sudhir Kumar, Registrar PGTC, who is instrumental in bringing this kind of programs to the breeders through the ISGPB Hyderabad chapter, as well as we thank Director of Research and Dean of Agriculture for their participation and mentioning about the importance of the panel discussion to improve our research programs. And finally, I thank all the participants in the hall for their keen interest and active participation, as well as I also thank the panelists answering patiently for all the queries asked by the participants. Yes, I thank the electronic wing for their support and facilitating the virtual discussion and making it without any disturbances the program successfully. So thank you one and all who have been participating in this discussion. Thank you very much.